Howdy, students. I'm here to talk to you about graphing notes. We're going to get into velocity time graphs. We're going to get into position times graphs, time graphs, and really everything that we can get out of them. So let's get right into it. So take note. We're talking about velocity time graphs here. And first of all, on our y-axis, remember this is our v naught, our initial velocity. It's wherever it started. We started here, but absolutely, you could start theoretically with some velocity. But we see a slope here. We note that this is an increasing slope, and we remember that we have slope change or velocity change over time. That is acceleration. So we can label this as change in velocity over change in time, and that equals a, or acceleration. And that's really anytime you have a change in velocity, it is acceleration. And this is a positive change, so it is an increasing velocity. For each second, we will have a higher velocity. And the other thing that we can get out of this, we figured out, is the displacement. It's how much you have changed in a given amount of time. So if we say that we're going to look at this time, we could figure out the displacement on from the velocity time graph. So if the slope is the acceleration, we go back the other way, and the area is so this area here, this entire space here is whoops, got a little wild there. But this entire area here, if you can figure that out, that is your displacement. And I'm going to change the color a little bit because this is a little more complicated. We had just a triangle. That's 1/2 base times height. If you have something like that, you can still figure it out. You just have a triangle, area of a triangle, plus an area of a rectangle. And pretend this is a nice, pretty rectangle. Here, just base times height. That's the area of a rectangle. And if you figure that out, that gives you the displacement. Remember displacement being change in position. Actual change in position. That gives us the displacement. And that's what we can get from this graph. We also can see graphs like that. So again, this is our V naught, but we also get, this is a different type of changing velocity. This is a decreasing velocity. So we know that it is going to be a negative sign here. We know it's a velocity change moving in the negative direction here. And we could quantify that too if we wanted to. If we called, said this is 4, this is 3, 2, 1, this is 0. We'll call this, just to do it, -2, -3. We'll call this -4. So we could say, that this is 1 second. Here, this is 2 seconds, 3 seconds. We see a negative velocity change. So change in velocity over change in time. We get a negative acceleration. Really that you could just calculate that out. If this is 1, and this is here, so we could call it 0.04 and 0.13. We figure out the slope. Slope is y2 minus y1 equals x2 minus x1. So we do 3 minus 4 over 1. 1 minus 0. We get negative 1 over 1, or our slope is negative 1. Now, if we said that this is velocity and it's in meters per second, and this is in seconds, I should put this in parentheses, we know it's negative 1 meters per second squared. And that is our slope. That is also our acceleration, meters per second squared. Another type of graph. Now, on the last one, it was decreasing, 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 decreasing until the velocity is actually 0. This right here means it's not moving. Not moving. And it has 0 velocity. If you have 0 velocity, you're not going anywhere. This is a negative 4 meters per second is your velocity. And again, it's not accelerating at all, but it does mean that you are going negative 4 meters per second. It means you are going, if this is your number line, down here, it would be 4 meters per second in the negative direction, is what that could mean. And it's also constant. Remember, constant velocities are just a nice little line. Let's get into a little more complicated graph here. And it looks, like it's not that different, but there's an interesting point right here. And we're going to think about what that point means. So if you are here, this is a v0, a starting velocity that is positive. So it means that you are moving, again, if we have our number line, you're moving in the positive direction. But it's going down. So that means that during this portion here, that you are going forward because you have a positive value, but you're slowing. And again, you start with any positive value. You start with a speed, and then you're going to go to 0. You're going to need to slow down until you get to 0. Here, even if it's just briefly, you're not moving because you have that 0 velocity again. And this is where it gets interesting. Because if you stop moving, but you continue changing your velocity, you're now going to go backwards because now you have a negative velocity. So now you're going in the opposite direction. If this were a car, it is moving in the positive direction. It slams on its brakes until it stops. And then all of a sudden it nails, throws it in reverse right at this point and starts going in the opposite direction. And it is going backwards. So going backwards. But it is speeding up. It is increasing how quickly it is going backwards, because this value is moving away from 0. So this means that here it's going backwards very rapidly compared to like right here. And this is just, if we have a nice change like this, a nice line like this, this is a constant acceleration. Remember, acceleration is just the change in velocity over time. Constant acceleration. And it's a negative acceleration. Negative acceleration. It's a acceleration moving backwards. It's acceleration that starts you moving forward until you hit a not moving point, and then you will start going backwards, not backing, backwards, and you will increase the magnitude. You will speed up going backwards. This is the opposite. Again, we have 0, we could do 1, we could do 2, we could do 3, let's call it 4. Here, we'll do -1, -2, -3, -4. So you see that starting out, you're going in the negative direction. You're traveling in the negative direction with a -4, and we could just call this meters per second, is our velocity. But again, we're going to go towards 0, so you're no longer going that far. Again, with a motion map, if this is here, over time, we would have just a changing just a little bit in this direction. And again, it's probably more likely over time. I mean, time we would move this way. Time goes on this graph, but in actuality, you're moving this way. So it would be, here you start with -4, and then you have -3, and then -2, and then -1 meters per second. So, the same amount of time, you're only going this far. And then, so I'm just going to label that as going backwards, but slowing again, because again we're going backwards, but we're slowing down. But here you stopped, and then again, if you hit, in a given period of time, you're not moving, and then you start accelerating. So here, you could even, maybe I'll even change colors so you can see a little bit better. But here, you are going to then, in a given period of time, move forward. And then, you get to this point and you're going even faster. And then this point, you're going even faster still. And this point, you're moving even faster. So, you would note, I want to point this out, that if you were traveling backwards but slowing down, you would hit a point where you stop moving. But then you would start moving forward, and if you take close notes, if you pay attention and you look at the area and you say this here is the same, these are both equal sides, we have an area here, it's actually a negative area. We have an area here, it's actually a positive area. If they're equal, our displacement is 0. 0 displacement. We didn't change. We started going backwards until we stopped, and then we started going forward until we hit the same point again. So 0 displacement. Which we could have said about the last graph too. But this is, again, we see a constant slope. And so this is a constant positive acceleration. Bop, bop, bop. There we are. Again, because of the positive slope. This is going back and slowing. This is going forward, and speeding up. Speeding up. Okay. Here, Now, pay attention. This is not a v anymore. Now we're talking about displacement. Or sorry, now we're talking about position. So in this graph, this is what we worked with initially, and this is the buggy car. This is the one where, in a given period of time, you go so far. In a given period of time, you go so far. So this is a constant velocity. It's just constant slope, just like we had with the acceleration before. But here, it's a little bit more complicated. And again, this is just position. So this would be an origin, wherever we start. This would be a negative starting point. This would be another negative starting point. We call that -1, -4. These are changing velocities, though. Changing velocities. Because this starts out with 0 velocity. It's not moving. And then over time, the slope gets a little higher. Slope gets a little higher. Slope gets a little higher. We see the increasing slope. So that means that the velocity is changing. This, if you assume these are very similar graphs, would show the exact same motion. We see the changing velocities. Again, if it's a changing velocity, remember that as an acceleration. This would just start from behind it. It would start from an initial position that is further behind. Again, not an initial velocity because we have our position, but the initial position would be slightly different. The -4 might start here. The -1 might start right here. If this is our number line here. But they would increase their velocities at the same time. And then we get this nice, interesting graph here. I've got 2 different things going on. But let's see if we can decipher them. So with our position time graph, we start at a given position. This could be 4 meters. And it starts moving very quickly. We've got a nice speedy velocity, but it's moving. If we call this 0, we'll call this 0. It's got a nice initial position, -4 or 4. We'll say this is 4 meters. If this is our number line, but it is traveling downwards. It is going towards 0. So we know it is moving backwards. However, over time, it's slowing. So this one, well, that wasn't a great one, but we'll say this one was definitely better and better. And then not quite at about maybe 1 is when it has almost no slope at all, and then zeroes out at maybe 1. We'll call this here. But then it starts moving back towards 4, and its velocity is going to increase again. So it's moving back towards 4. The position of 4 right here. And by the time it hits 4, it is back to the velocity that it started with. Again, we don't have numbers here, so it's very hard to tell the slope, but we know that the velocity is going to be higher, so we see a little bit farther arrow. This side, though, this is starting at, we could call this a -4, and we also see it moving towards 4, so we'll say it's -4. It starts with a fast velocity moving towards, not 4, but the origin. So maybe I'll even try to make those a little bit better. We'll move it back here. So we'll make them very comparable in a given time period, 1 second. It's going to move very far. But again, it's moving towards a flat slope. A flat slope means 0. But it won't do it at 0. It's going to do it a little bit before 0 is where it's going to reach a velocity of 0. And if it reaches a velocity of 0, it is not going to move. These are our arrows for the same period of time. So we're saying it's stopped at about here. And then again, it's going to start moving back in the negative direction. So in that negative direction, it's going to increase speed in the negative direction. And again, I'm not doing a perfect job. But you see these arrows getting a little bit faster. Again, it's 0 here. So this is where there's like no movement, where it's stopped. But it changes direction because the slope becomes a higher magnitude. We see in a given period of time, we see a greater change for this time, whereas for maybe the same amount of time here to here, we would only see maybe a little tiny bit of change because it's got a smaller slope. All right. I hope that was at least a little bit helpful.